All right, so this is number 9 from the worksheet. That's going to be due next week on Monday, Tuesday, depending on which class you're in. We're going to go through it real quick, and if you have any questions or something you're not sure where it comes from, you gotta let me know. So amplitude, let's first I'm going to show you the letters where they go. A is the coefficient of sine, which in this case is 1. B is 3. C is 2 pi over 3, and D is this -2. So the amplitude is the absolute value of A, which is the absolute value of 1, which is 1. Period is 2 pi over B, which in this case is 2 pi over 3. So I'm going to come down here and do frequency, just flip that upside down. So that's 3 over 2 pi is the frequency. Okay, intervals. I got to take 2 pi over 3 and divide it by 4, which would be 4 over 1. So I'm going to tell you right now, when I do a divided by 4 thing, I flip the 4 upside down and multiply by the reciprocal of 4 when I have a fraction right there. So that 2 and that 4 will reduce, and this is going to be pi over 6 as my intervals. So I'm going to tell you right now, this one is going to be an ugly one, okay? And the way well, let me show you why I know that. So then I'm going to do -2 pi over 3, and then that would be divided by 3, because B is 3. But again, because B is 3 over 1, I can flip that 3 down here, because I want this to be black. Because I am dividing by 3 right here, I flip that upside down, so this is going to be -2 pi over 9. Vertical shift is D, which is -2. We got this done. Now, how do I get the range? What do I do? Amplitude. -2 minus 1 would be a -3 here. And -2 plus 1 would be a -1 here. I don't know if you noticed, but I'd already done that in my head. So I moved the x up a little higher. Okay, now I want to tell you this is a terrible hard problem, and here's why. This phase shift and my intervals have different denominators. The denominators are different, which makes this an awful problem. Okay? So I'm going to show you what to do if you have different denominators in those. Because the phase shift is going to take the y and move it left or right. In this case, because it's negative, it's going to take this y-axis and move it left. And this vertical shift is going to move the x-axis up or down, the fake x-axis. So this is going to move the x-axis down too. Well, the x-axis is the easy part, so I'm going to put it on there first. So I'm going to go 1, 2, 3. And I could quit there because -3, right? This is my min. This is my max. So I've really got all the numbers on here I need right now to graph it. Do you understand what I'm saying? If you want to put more up here, you want to come up here and put a 1, you can. You want to come down here and put -4, you can. But you're only going where your range says. So you could have quit at -3 and going from negative down to -3, because this is where the graph's going to go between these two. Okay, and then I'm going to put in my fake x-axis. It's supposed to be parallel to the real x-axis. So that's the fake x. Okay, now this one is kind of ugly. So normally, and that is terrible for parallel to that line above. You come out here somewhere and you put a tick mark. You go halfway between, put a tick mark. Halfway between those two, put tick marks. And we do this. I'm going to move this up a little. I can't stand it. I'm an anal retentive math person. So we come out here, try to get the same distance as that one, put a tick mark, cut them in half, and cut those in half. So normally I would start with pi over 6, and I would start going out this way, and this would end at 2 pi over 3. Okay? But because these denominators are different, I have to do it differently. So you ready? So what I'm going to do is I'm going to get common denominators of these two. Does anybody know what the common multiple is of 6 and 9? You know how to find common multiples. There's two ways to do it. Do you know how? How many know how to do it? Not one of you. Okay, one of you. That's not enough. So here's two ways to do it, all right? You're getting the least common multiple for what's called the least common multiple. So if you take 9 and you break 9 down to 3 times 3, and you break 6 down to 2 times 3, what you do to find the LCM, the least common multiple, is you take whatever's in common. If there's any factors in common, you write it down. Just one for the common multiples. Now, if there were more, I'd circle the two others and write down one for those, but there's no more. So then you must multiply by everything else not there. So 18 is my least common multiple. There's another way to do it. You look at your number, you take your number 9 and you do multiples of 9. Now you could keep going. In other words, 1 times 9 is 9, 2 times 9 is 18, 3 times 9 is 27. And then you take your other number and you start doing common multiples. So 1 times 1 is 6, 2 times 6 is 12, 3 times 6 is 18. And if you look, the first one you come to that's the same, that's your least common multiple. So either way works. So I know that I've got to get this to 18 on the bottom, so I multiply this by 2 over 2, which means I'm going to have negative 4 pi over over 18 is going to be my phase shift. Up here, I got to get 18, so I'm going to multiply this by 3 over 3, which this is going to give me 3 pi over 18. That's my tick marks. So I'm going to write my tick marks with 18s. Are we ready? Okay, so this is going to be 3 pi over 18 plus 3 more pi over 18 makes this 6 pi over 18 plus 3 more pi over 18 makes that 9 pi over 18 plus 3 more pi makes that 12 pi over 18. And then I'm going to do the same ones going this way. Negative 12 pi over 18. Negative 9 pi over 18. I got the ones on the left too close together. Negative 6 pi over 18 and negative 3 pi over 18. Anybody got a question where that came from? Now I want you to see something. I'm going to erase it, but I'm going to show you this. If I reduce these fractions, oops, wrong button. If I reduced this 3 over 18, this would be pi over 6, right? This would be 2 pi. If I divided these by 3, this would be 2 pi over 6, right? 2 pi over 6. This would be 3 pi over 6, and this would be 4 pi over 6. I hope you can see that we're still going by pi over 6, but the fractions I wrote differently. You understand what I'm saying? In other words, 1/2 is equal to 6/12. So if I go by 6/12 or 1/2, it's the same thing. You understand what I'm saying? Yes or no? Now, if I were doing this without changing these, I would reduce this to pi thirds, this to pi over 2, and this one to 2 pi over 3, which is that period, 2 pi over 3. Okay? But I just wanted to show you, these are still the tick marks that I got up there, just with a different common denominator. Okay? All right, now we're going to phase shift this thing. And it says we're going left because it's negative 4 pi over 18. Well, is negative 4 pi over 18 on there? Is it on my tick marks? No. But because this first tick mark is negative 3 pi over 6, and this is negative 6 pi over 6, if I think about it, if I had a negative 4 pi over 6 and a negative 5 pi over 6, they'd be like that, wouldn't they, in thirds? Are you with me or not? So that negative 4 pi over negative 4 pi over 18 is going to be that tick marker right there. So I'm going to use my magic machine here to draw a new dashed y-axis. I'm going to try to get it parallel and use this machine because it's wonderful. Not parallel, I don't like it. That's closer. I'm going to just go with that one. So this thing is going to be my fake. This is my fake y-axis. So I'm going to call this y prime. So right here is my new origin. I'm going to start from there. Okay, so you see how nasty this problem is? I don't think the quiz problems are probably this nasty. I'm pretty sure he won't make them nasty. I'm going to do purple. So where's sine start? It doesn't. Where's sine start? Nope. Where's sine start? 0. Origin. So in case you didn't, I don't know, did you write this down? Sine starts, write this down if you don't have it yet, at the origin. And it goes, and the origin is a 0. So it goes 0, max, 0, min, and it continues that pattern forever. Cosine starts at a max. So it goes max, 0, max, min. That second one should be a min, not a max. Max 0, min 0, and it continues that pattern forever. So I'm going to come down here to 0 and put a dot. Then we go to the max. If you've forgotten what the max is, there's two ways to know. One is you come down here and look at your y value of your range, or you can look at your amplitude, and that tells you how far to go up. So at my next tick mark, now, do you see how that's just to the left of the tick mark? So that means my next one's got to be just to the left of the y-axis. So my max is going to go here. And then my 0 is going to go just to the left of the next tick mark. And then my -1 down from this, or if you look over here, the min's -3, that's going to be just to the left of that tick mark. And then just to the left of that tick mark, and then back to a max just to the left of that tick mark. And then I keep that pattern going. So just to the left of this tick mark is going to be a min. Just to the left of this tick mark is going to be a 0. And just to the left of that tick mark is going to be a max. And I'm going to draw that in, and that's what my graph looks like. Remember, no mountains. I did talk to you about mountains on Tuesday, right? Yes or no? And don't go above the maxes, turn it back down. So it says 2 periods. So do you see that I have 2 periods here? Just to make sure we see, one max to another max is 1 period, and that max to this max is a 2nd period. So it gives me 2 periods because you got to graph 2 periods. Yes?
Does the period not mean anything on the graph besides getting the frequency?
The period is how long it takes the function to start repeating. Okay? So let me just show you. If you, just to relate to what we've already dealt with, remember the unit circle? Remember we started 0, this is pi over 2, this is pi, this is 3 pi over 2, and then back up here at 2 pi. See, that's why 2 pi is the normal period for sine and cosine, because you come around to there and that starts a new cycle. A cycle or a period is how long it takes you to get around the circle. And that all changes depending on your bead. Are we thumbs up on it or not? Everybody? Fine? So tired you can't even lift it, yeah. Okay, frequency is how frequently this wave is going up and down, the reciprocal of it. So like on your radio stations, like you listen to whatever frequency you listen to, you have to turn it to get there. Your receiver in your car on that radio that frequency is made to hear the radio waves coming in at that same frequency. Okay? So like if you listen to whatever frequency you listen to, That's how that works. That's causing the waves are coming at that frequency, so that part on the radio responds to only that frequency. That's how it gets different stations. It's based on those waves, of the frequency of the waves. Yeah.
I have a question. So for like number one, this worksheet, would 3 be the amplitude? Am I switching it around?
Yes, 3. Oh, no, 3 is not the amplitude.
It would be
The
one.
amplitude goes in front of the sine.
So what would I do with the 3?
I would distribute the 3. I would write that problem down. Oops, wrong thing. For number one, I would write down y equals and distribute that 3 and say that it's 3x minus 3 pi. So that 3 is your b. Okay? Anybody else? Anybody got any questions on the book stuff over here? Okay, you got almost 20 minutes to work on your problems. 20 minutes to get going on this. I did pass out the take-home quiz, right? Okay.